Hello, you guys. Let's start on Chapter 8. Can you believe it's already Trimester 3? Wow. All right, so take a look at the goal. Use graphs to represent relations and functions. So a lot of vocabulary here. A relation is any time you have an ordered pair. Like remember when we did x, comma, y. So anytime we're comparing an x value with a y value, that's called a relation. A domain would be all of the x values. Range, all of the y values. If I call them inputs, I'm talking about all of the x values. If I'm calling them outputs, I'm talking about all of the y values. And a function has all inputs, x's, are different. And we'll talk more about that in this lesson. And then there's a really easy vertical line test that we can use so to decide if something's a function or not. And what you want to watch out for is if you ever have a situation where one point is stacked directly above another, then it is not a function. Okay, and please in the margin here, can you write y equals 2x plus 3? And you're going to see us use an x column, a work column, and a y column. So we make up values for x. For example, easy numbers to input. 0, positive 1, positive 2, negative 1. And remember, all the x values are called the domain, or you'll hear me say the inputs. And then we do a little bit of work. So here, if y equals 2 times x plus 3, I write 2, and then I put parentheses and leave a space for the x value plus 3. So if I input 0, 2 times 0 is 0, plus 3 gives me 3. And 3 is an output. It's also the y value. So we call the y values, the range, we also call them the outputs. If I would input a 1, 2 times 1 is 2, plus 3 gives me 5. If I input a 2, 2 times 2 is 4, plus 3 would give me 7. If I input a negative 1, 2 times negative 1 is negative 2, plus 3 would give me a positive 1. Alright, take a look at example 1. They want us to identify the domain and the range of a relation represented by the table below that shows one Norway spruce tree's height at different ages. So notice the first thing they gave us, the ages, the years, that's the x. The first item is always the x. And they said after 5 years, 10 years, 15 years, 20 years, and 25 years. And then they measured the height, and that's the y. So after 5 years, it was 13 feet tall, 10 years, 25 feet tall, and so on. Now, a really easy way that my algebra kids came up with remembering domain and range is they just thought like Dr. Pepper, D-R. So the x is always the D, and the y is always the R, the range. So the relation consists of ordered pairs. For example, this first set, 5, 13, we could write it as an ordered pair, 5, 13. And then 10, 25, and then 15, 34, and then 20, 43, and the last one would be 25, 52. Now, if they just ask us to identify the domain, you want to look up here at all of the x's. And here's the deal. You have to list all of those x values in order from least to greatest, and you can never repeat a value. So it's good that they're all different. So this would be 5 and then 10, 15, 20, 25. They were all different. They were already in order. Now if they ask you for the range, you look at all of the y values and you do the same thing. You take all the numbers that they give you and you write them in order from least to greatest, and you never repeat a number. So in this case, they were already organized for us. So 13, 25, 34, 43, and 52. So we have the domain written as a set and the range written as a set. Alright, you guys, take a look at example 2. Represent the relation. And then they give us negative 3, 2, negative 2, 2, negative 2, and so on. And they want us to use a graph to represent it. Well, the first thing you want to do is just graph the ordered pairs as points in a coordinate plane. So if I graphed negative 3, 2, start at the origin, negative 3 tells me to move to the left, and then get in the elevator, 2 tells me to go up, and I put a point there. Then negative 2, negative 2, start at the origin, go to the left 2, and then go down 2 and put a point. And then 1, 1, start at the origin, go to the right 1 and up 1 and put a point. 1, 3. Start at the origin, go to the right 1, and then up 3 and put a point. And then 2, -3. Start at the origin, go to the right 2, and then down 3 and put a point. Now, once you do this and you see these points, I want you to notice something. See how here there's a point stacked right above a point? Whenever that happens, when they're stacked right above each other, and you could draw a vertical line through it, that means this is not a function, okay? It's a relation, but it's not a function. Now, another way that we're going to use, and I'm going to ask you to cross this out. The mapping diagram really confuses people, so I'm not going to use a mapping diagram. What I'd rather you use is a table method, and that works really well. So take all the points that they gave us, and I want you to make an X, Y table. So do an X, draw your line, do a Y, and then since they gave us 1, 2, 3, 4, 5 points, I want you to make 1, 2, 3, 4, 5 spaces for the points. And I want you to just copy the numbers they gave us. See how they gave us -3, 2? Put -3 for the X and 2 for the Y. And then -2, -2. Put -2 for the X and -2 for the Y. 1, 1, put a 1 and a 1. 1, 3, put a 1 and a 3. 2, -3, put a 2 and -3. Now remember, the domain is all the X values, and that's the only place you have to look. Look at just the domain, and if you ever see this situation where the X is repeated, then it is not a function. It's another way to see that these points did not make a function. Okay, so take a look at example 3. Tell whether the relation is a function. Well, the relation in example 1, I wrote it right here. I took all the X values. Remember, this was about the tree. And I put 5, 10, 15, 20, 25, and I did all the Y values, 13, 25, 34, 43, 52. And for example A, the relation is a function because all of the inputs, the X values, were different. If they're all different and none of them repeat, then you'd say, yes, this is a function. Now take a look at example B. Example B was right up above, but I copied it here so it'd be on this chart too. If I take all the X values, the -3, -2, 1, 1, and 2, and all the Y values, 2, -2, 1, 3, and -3, and I just look at the inputs, at the domain, and you noticed, and we talked about this already, that the 1's repeated. Well, that tells me this is not a function because the input of 1 repeated, and that's not allowed in a function. Okay, so the checkpoint, they want us to identify the domain and range, and then tell whether it's a function. So they gave us 1, 2, 3, 4, 5 points. So do your X and your Y chart, okay, your table, and then copy the values. So -5 was the X, 2 was the Y. -3 was the X. Oops, that should be a -1. Sorry, let me fix that real quick. And -1 was the Y value. And then -1, 0, so I put -1 for the X, 0 for the Y. 2, 3, so 2 for the X, 3 for the Y. And 5, 4. All right, and so my domain, if I have to tell, they want me to identify the domain. So take all of the X values and you put them in order from least to greatest, and you don't repeat. So they were already in order from least to greatest and nothing repeated, so I just copied them here. Now for the range, I have to do the same thing. I have to take all of these values and I have to put them in order from least to greatest. And now I see I made a mistake here with that -1. So let me fix that. So this should be -1, 0, and then 2, 3, 4. And now to decide if it's a function or not, I just look at the inputs, only the inputs. And notice how they are all different. If they are all different and nothing repeats, then I say yes, it is a function. Okay, take a look at number 2. So again, for number 2, I'm going to take these values and I'm just going to write them in an X and a Y table to help organize them. So I put -4, -3, then I put -3 and then 2, and then 0 and 0, 1 and -1, 2 and 3, 3 and 1, 3 and -2. And so now I take the domain, I look only at the x values, and I put them in order from least to greatest. So that'd be -4, -3, 0, 1, 2. And notice how even though the 3 repeats, I only put it once when I'm listing the domain. You never repeat a value when you're listing the domain and range. Okay, and now for the range, I have to put all these numbers in order from least to greatest, and I never repeat. So that would be -3, -2, -1, 0, 1, 2, and 3. And now I have to decide if it's a function or not. So again, look only at the domain, the x values, and notice how the 3 is repeated. As soon as the 3 is repeated, this meant it was not a function. Okay, so look at example 4. In the graph below, no vertical line passes through more than one point, so the relation represented by the graph is a function. And I want you to notice, please make these points bolder so you can see them. And no matter where I would put a vertical line, there is never a place that one point is stacked directly above each other. You know, like putting two Legos on top of each other. They're not. And so it would pass the pencil test, so you would say, yes, this is a function. Now take a look at B, and I want you to go over with your black pen. Make these points really stand out. And then I want you to notice with your red pen, if I drew a vertical line, you'll see that these 2 points are stacked right above each other. And that's not allowed in the function world. So this is not a function.